All right, 2.1, linear and quadratic functions and modeling.
Is this hard?
I mean, I don't really think so.
I don't think the math major is the appropriate person to ask if it's hard. Sure, maybe I got
All right, let n be a non-negative integer and let a sub 0, a sub 1, a sub 2, dot, 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 a sub n minus 1, comma, a sub n be real numbers with a sub n not equal to 0. The function given by f of x is equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot 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 plus a sub 2 x to the 2 plus a sub 1 x plus a sub 0 is a polynomial function of degree n the leading coefficient is a sub n. Zero function f of x is equal to 0 is a polynomial function it has no degree and no leading coefficient. Polynomials are polynomial functions of no and low degree. So we're going to need a table with 3 columns and 5 rows.
Can we back up just a little bit?
Alright, I'm going to list off all the ones that we're going to do, and then we'll do the form and the degree in a second. We're going to have a zero function. We're going to have a constant function. We're going to have a linear function. And a quadratic function. So our zero function looks like f of x is equal to 0. Constant function, f of x is equal to a. For a not equal to 0. Linear function, f of x is equal to ax plus b. For a not equal to 0. And quadratic, is f of x is equal to ax squared plus bx plus c for a not equal to 0. So the 0 function has a degree that is undefined. Constant function has a degree of 0. Linear function has a degree of 1. And a quadratic function has a degree of 2. Okay, that's coming from whatever the highest x power is that is in the function itself. Alright, so linear functions. A linear function is a polynomial of degree 1, and it has the form f of x is equal to ax plus b, where a and b are constants with a not equal to 0. A line in a Cartesian plane is a graph of a linear function if and only if it is a slant line, not horizontal or vertical. Average rate of change of a function y equals f of x between x is equal to a and x is equal to b, assuming a is not equal to b, is f of b minus f of a all over b minus a. Okay, so that's essentially, when you hear average rate of change, you should think slope. You have a theorem. A function defined on all real numbers is a linear function if and only if it has a constant non-zero average rate of change between any 2 points on its graph, rate of change is equal to slope, which is equal to m, which is equal to rise over run, which is equal to delta y over delta x, which is equal to y2 minus y1 over x2 minus x1. For my stats people, the next part is going to be very easy for you. Linear correlation and modeling.
Why are they mixing?
Because this section has the and modeling
Can you go
part.
just a little bit more, please? I'm sorry. I'm like really confused. Just don't look at what you're writing and just listen. No, I got behind at the top because like I forgot to write something. I had to go back and now I'm just like all out.
Positive slope has positive correlation.
This morning? Yeah. What is going on?
Negative slope has negative correlation.
It's really not that hard.
I mean, it makes sense.
No, like
Positive,
actually
positive, negative,
this
negative.
isn't hard. This isn't hard stats.
Technically, this is what we did last year in Algebra 2.
This is really.
Oh, yay.
No, it's not. You're just drawing points in a line. You're drawing dots.
So we're doing.
It's difficult for me. Oh, I do remember this actually.
Oh, so this is
They're
not
like
that
scatter
hard.
plots. They are scatter plots. But like, I lost the name.
Good job.
You like just got them done.
Yeah. I was washing my hair and it got stuck. It was lifting and it got stuck under my hair and I just like moved it and it like ripped off. It was like.
That's very unlucky.
Oh, it's not very They haven't went out yet. Oh, we need the dots or? Uh-oh. I'm not there yet.
Oh, there are 5? I thought there were.
Yeah, I had to add one, my bad.
That's what I feel like.
Oh my gosh.
I couldn't
this
count
isn't
either.
Interweaving. This isn't good. We'll be fine.
I don't like this.
This one is. These ones aren't hard. Yeah, because there's no words with them. Yeah. Yeah. Don't take stats unless you want to be in English. It's in English and in math.
Alright, so this first one is strong positive.
So we do have words underneath them, really. Strong positive.
Second one, moderate or weak positive.
Plus, you don't have to read something and figure out what that is.
This is just notes.
Oh,
Oh,
shoot.
dang.
Little or no correlation. Whoa. Strong negative. Moderate or weak negative. The correlation coefficient.
Should have given more room between them.
R is the number.
Don't call them
that measures strength.
Something we need to have.
Oh Lord, this is a problem. Is it something you need to have memorized?
Yeah, like, do we need to know, like, let's say for the test, like, do we need to know what all of these look like and then the names for them? Like, off the top of our head?
Possibly, yes.
Okay.
Yeah.
I'm very happy I'm taking stats.
But it's gonna be more of a concept
It's
thing.
really easy because if they're close together, they're strong. If they're far apart, they're moderate or weak. And if they're really far apart, they're really weak.
Oh.
That's all.
Are
there
we
is to
actually
it.
doing any numbers with the correlation or no?
And you don't really have to remember positive and negative because if it goes the positive.
This is
way
like the
that you
point
know
2
it's-
and the point 8 thing like we were doing. In
Do
stats,
what?
or will it be different?
I'm gonna put them up in a second.
Oh, well, I spoiled it. Sorry, guys.
I'm just waiting for the pencil momentarily and letting people catch up.
Thank
'Cause
you. I'm very behind. Oh, you're literally writing it right now. Sorry.
So what? That measures what?
Hey, this will be on our test today. In stat. Yay, quick review, guys. Well, never mind. Just quick
No,
review.
I'm just gonna stay with stats.
Yes, click review.
I got a 99 last quarter, but you know, maybe this quarter I'll get a 90. Balance it out.
I'm gonna see if it'll let me do this.
What quarter did you do last?
Oh, I wouldn't
I
write
got
with
a
my
99.
finger. It would
Count
work.
stats in chemistry. When you have
No, it's gonna be really bad.
It's
It's
not
like
high because you have it. Oh yeah, there you go.
Well, at least we know what the next word is.
She already said it out loud. I remember.
Well, you know, it's okay.
the measure strength and direction of the linear correlation of the data set
Oh, this sounds a lot like stat. It's like stats now.
You guys are so bad.
All right. Properties of the correlation coefficient.
Is this?
And there's going to be 6 of them. -1 is less than or equal to r is less than or equal to 1. When r is greater than 0, it has a positive linear correlation. When r is less than 0, it has a negative linear correlation. When the absolute value of r is approximately 1, okay, what we say is 0.8 or above, it has a strong linear correlation.
Very unusual to happen. Well, for it to be one.
If it's 1, I think I'd be so happy, but it's never 1.
When the absolute value of r is approximately 0, so we say less than 0.2, it is weak or no linear correlation. And when 0.2 is less than the absolute value of r is less than 0.8, we say it's a moderate linear correlation.
I don't understand how you write so fast. Like, I was literally caught up with you, and now I'm like 2 points behind.
It's because you don't listen and you just look at the board.
No.
If you listen and don't look up, then
Oh my gosh,
Right
Berkeley.
Taylor.
It's actually juicy.
I
Not like a
know,
dig,
but like
it's
I,
just like
well, what happens is I like
think that's what you said.
But I'll already start writing slower, and she'll be on the next point while I'm still trying to write down what
Well,
she
you
said.
write faster.
Is there a
Well,
lot
I'm
more?
not fast.
Wait, can you go up a little bit? I didn't get to finish. There. I'm done now.
The sad thing is I have to rewrite all of this.
Oh, it's correlation.
I guess I left my notebook at home when I was studying. And yes, so.
Is that like in parentheses 0.8 or above?
Yeah.
Okay.
Oh, sorry, Berkeley. There. I know you hate it, but I had to.
Aggressive.
It's like stop
She does
working.
it all the time.
When I
it's
make
so
it,
annoying.
it works, okay?
All right. Quadratic function,
Stop. Yeah.
polynomial
Here. How many lines is this gonna take?
of degree 2. A lot more.
No, but just the quadratic form.
Pretty much everything that's left is going with this.
Okay, so I'll put it over there.
All right. With this, the axis of symmetry goes through the vertex. Go from vertex form to standard form. Ax squared plus bx plus c. So in vertex form, we would have, oh wait, I thought it was dead again. F of x is equal to a times x minus h squared plus k, which would give us a times x squared minus 2hx plus h squared plus k. Okay, and that is all I'm doing is just foiling the x minus h squared for that step. So then I would get ax squared plus negative 2ah times x plus ah squared plus k. So just so you can see the form, okay, the negative 2ah is the constant in front of x, and then ah squared plus k is the constant term. Okay, what would be c? So this is c, this is b, and then obviously that's a. There. So that then gives us ax squared plus bx plus c. And so that went from vertex form to standard form.
But you say you're the best. Yes, you do.
All right, vertex form. Like I said, it starts as f of x is equal to a times x minus h squared plus k. The vertex is at hk. Okay, notice this sign is negative. If this was positive, then this would be negative h. Okay, so it's always got to be negative and then positive. If that is not the case, then the signs of the actual vertex are flipped. Okay, axis of symmetry is that x is equal to h. H is equal to negative b over 2a. So if you had the other form, that's how you would get that. And k is equal to c minus ah squared. Okay, now if you'll note this h here, this is how we get this. This is part of the quadratic formula. Okay, it's the negative b over 2a part, so it's everything from the quadratic formula except for what's under the radical. This is or when a is greater than 0, it opens up. A is less than 0, it opens down.
We have 3 Mutos.
Alright, one more thing. I'm going to try to get in here really quick.
Oh, we have like 1 point on the next page. That's so sad. Oh.
Alright, vertical, free fall motion. Okay, a little intro to physics here. The height S and vertical velocity V of an object in free fall are given by S of t equal to -1/2 gt squared plus v sub 0 t plus s sub 0, and v of t is equal to -gt plus v sub 0, where t is time in seconds, g is approximately 32 feet per second squared, which is approximately 9.81 meters per second squared. Okay, the 9.81 meters per second squared, if you take physics with me, is the constant that we will use. Is acceleration due to gravity v sub 0 is initial vertical velocity of the object, and s sub 0 is its initial height. And you'll probably need, for examples, like 2 pages
2 more pages?
for examples.
Oh.
Is that